So just don't allow yourself to get overwhelmed by this problem. And it does not even have any negative exponents, okay? Just look through this, okay? And right now, again, I wouldn't even focus on the exponent, right? So I would just look on the inside of the parentheses here. Let's pull this out. We'll come back to this once we get it simplified, okay? So eventually, I'm expecting something that is simplified here. I don't really know what it is yet, but I'll put it in the parentheses and then I'll apply the exponent of 3 when I get this simplified. Now, when I look at this stuff that I have here, focus on each of the bases separately. So what I mean by that is look at your numbers. You got 17 and 2. Look at those separately. Then look at your x's, and then look at your y's, and then even the a to the power of 0. Instinctively, for me, I want to make that a 1 right now, but I'm going to wait. Just so we know, focus on one at a time. Don't focus on them all at a time. So here's what I mean by that. Let's look at just the numbers on this, okay? So that's 17 over 2. Is there anything I can do with 17 over 2 to simplify that? There is not. So in my parentheses, I've just evaluated 17 over 2, simplified it. Didn't evaluate, I simplified it, okay? Next, I would look at my x's, right? So I got x to the power of 18 in the top, x to the power of 8 on the bottom. So that would be x to the, it's division right there. So I'm going to take the two exponents, 18 and 8, and subtract them. And that would be, it should end up being x to the power of 10. Now this x to the power of 10, there does arise some questions on where does this go? Does it go on the top or the bottom? Because I made the fraction, right, from my 17 over 2. You can know, depending on which of the two, the numerator or denominator has more. So there's 18 x's on the top, 8 on the bottom, so there should be 10 left on the top. So that x to the power of 10 needs to stay on the top. Now that's kind of the foundational way to look at kind of. The other way to know is that we did 18 minus 8, we got a positive exponent. Positive exponents will stay in the numerator. If I got a negative exponent, then I would put it in the denominator. Next up, we got the y's. So again, y to the power of 19 on the top over y to the power of 8 on the bottom. So I'm going to take my y base, my exponents of 19 and 8, and subtract those. That should be y to the power of 11. So there should have been 11 extra y's on the top there. This a to the power of 0, anything to the power of 0 is 1. So it pretty much just kind of goes away. I mean, you're welcome to cross that out as a phantom 1 if you'd like. I don't really need to show that 1 there because anything times 1 is itself, so let's get rid of that garbage. And that simplifies everything on the inside of that set of parentheses, okay? So now that I have that, let's take this stuff and just kind of, again, just condense it, give ourselves a little bit of extra space there. But it's still to the power of 3, okay? So after all that simplification, I'm now left with only just a 2 on the bottom. That's still not a problem. But what I am ready to do is to take the exponents, so the 17 and 2 have 1 exponent. I'm going to take that 3 and multiply it by all the exponents of the bases. Okay, so I still have my same bases of 17 and 2 and x and y. But now applying this 3, and by apply I mean multiply, so 17 to the power of 1 times 3 would be 17 to the power of 3. X to the power of 10 times 3 would be x to the power of 30. Y to the power of 11 times 3 would be y to the power of 33. And then 2 to the power of 1 times 3 would be 2 to the power of 3. Now that looks pretty good, but I'm kind of assuming that they're going to want us to evaluate the 17 to the power of 3 and then the 2 to the power of 3. 2 to the power of 3, of course, isn't too bad. You'll have to decide about the rest, though, but I got base x and y. We know those exponents of 30 and 33. But then I've got, in the calculator, 17 to the power of 3, enter. Oh, it's pretty big. 4,913. And then 2 to the power of 3, boom, is 8. Now, you should just check 4,913 divided by 8. Can that be simplified? It cannot. How do I know that? Because the original fraction, 17 over 2, could not be simplified. If it could have, then we would have. and then we would have simplified it back then. But since it couldn't be simplified, this can't be simplified, and we can prove that. 4,913 all over 8 in my calculator, and it just gives me the same fraction back. So the calculator will simplify the numbers for you if it can. But again, you can kind of know back here, when we did this part right here, that was fully simplified, that means this can't be simplified either. That's some prime factorization stuff if you're interested, but I assume you're not either.